Okay, and it records the screen that I'm sharing, right?
Yep.
Okay, cool. All right, hello everyone. Welcome to learn.py session 3. If you would like to follow along our slides or with our README, you can find the links right here, and I'm sure a mentor will send them in the chat. And additionally, if you're keeping up with the ACM membership portal, we have an attendance code here. And we also love when you fill out our feedback form, as it helps us improve our workshops. And the link for that is right here. And also filling it out gives you a chance to win money. So there's definitely a great incentive to do that. So before we start, we just have a quick plug for Hack Kitchen by Chandra and Christina.
Thank you, Jakob. Hey guys, it's your friendly neighborhood Hack Kitchen directors here to announce this year's virtual Gordon Ramsay themed Hack Kitchen. So if you find yourself feeling hungry, if you find yourself liking Gordon Ramsay roasting people on the internet, if you just like coding, if you want to use all this amazing Python knowledge that you guys are learning in learn.py, then you got to pull up to Hack Kitchen, and we have lots of prizes. We have lots of fun stuff, lots of fun people. Yeah.
Hello, it is your other friendly neighborhood Hack Kitchen co-director, Christina, and I just wanted to mention that our applications are due the Monday or the Sunday of the week before week 6, and you have the option to do a day Hack Kitchen versus a night Hack Kitchen for those who are in international time zones. So I highly recommend you sign up because there's lots of cool coding puzzles that all relate back to Gordon Ramsay, and we also have, like Chandra said, a lot of prizes. So we hope to see you there. Thank you, Jakob.
Yeah, no problem. Okay, so as a quick refresher, the last 2 sessions were Intro to Python and Data Structures in Python taught by Einar and Nare. They did a great job. And this week, Alex and I are going to be doing Python classes and inheritance and a little bit of scopes. Okay, and yeah, just as a brief overview, we're going to go through a brief intro to scopes, and then we're going to go into classes, which is going to be instantiation with the init function, and then basically what to do after that once you have a class. So accessing data attributes and methods. So we're going to start out with a question. Actually, we're going to start out with a very quick demo. So I'm going to do that. Let me just go to VS Code. Okay, so I'm just going to briefly demonstrate, and then we're going to explain more in-depth scopes. So I'm just going to call this demo that less specific scopes cannot access more specific. So I'm going to have a variable called less specific. And I'm just going to set it equal to 5. And then I'm going to create a function. And oh wait, just a sec. I just realized this file does not have a .py name. Oh, here we go, save as. .py. Okay, there we go. Okay, so and then I'm going to create a variable called more specific and set it equal to, oh, something in the chat. Okay. So, and then more specific equals 2. And then just in this function, I'm going to print inside foo, and I'm going to print less specific. Okay, now what's this there? Oh, I have 2 equal signs. Okay, and then I'm going to call foo. So let's run this. And it worked perfectly fine, right? So in this function, foo, we were able to access less specific. However, if I were to try to print more specific, the variable that's inside foo, outside of the function, let's see what would happen. And I get a nasty error, right? And it says name more specific is not defined. So that kind of brings us to our question over here. Let me just present this again. At any point in my program, what variables and functions do I have access to, and does it matter where I am in my program, to access those attributes? And in short, the answer is yes, it absolutely matters. So that brings us to scopes. What a scope is it defines where in your code variables and methods can be accessed. So that means that more specific scopes can access less specific scopes, but not the other way around. So less specific scopes cannot access more specific scopes. So I like to think of this kind of like a telescope. So basically, if I have a telescope that cannot zoom in very far, I can't zoom all the way in to see something that is past its zooming capabilities. Whereas if I have a telescope that can zoom in really far, then I can always zoom that telescope out and see the bigger picture. So my more specific telescope can always zoom out and see the less specific stuff, but my less specific telescope can't just zoom in and see the more specific stuff. So that's kind of like an analogy for how scopes work. Okay, so, and here's just a quick side note. For those of you that may be coming from C++, or maybe you just haven't been familiarized with this yet, functions in Python can be nested within other functions, which is super cool. And these functions have a really, really complicated name. No, I'm kidding. They are called nested functions. And here's like a quick example. Oops, sorry. If I have a function A, and within this function A, I have a nested function called B. And then, so in B, I print hello from nested function. And then after that, in A, I print hello from outer function, and I call B. So if I were to call this function A, I would print out both methods because I can use the nested method in A. So just as a proof of concept, I'm just going to demonstrate that quickly. So I'm going to erase this. And by the way, all of the example code that we're using can be found in the same GitHub repo as the README. So let's just do that quickly. I'm going to create def A and then def B. I'm just going to do exactly what's on the slides. Hello from nested function. And then in A, I'm going to print hello from outer function. Okay, and then I'm going to call B, and I can do that because I'm still in A. Okay, so now if I were to call A, what is this error? Unused variable. Oh, okay, I just have to save the file. So now if I run this, I'm going to see that first it runs, when I run A, I'm first going to do this. So I print and I get hello from outer function, and then I call B, and in B I print hello from nested function, and that's what I get. So that's just kind of a demonstration of nested functions. Okay, now, so let's go over the types of scopes. Now, looking at this code, this may look like a lot of code right now, but as we can see, there's 4 different types. I just called them scope A, B, C, and D. And this probably looks like a lot, so we're going to break this code down piece by piece just to kind of figure out what each piece means. So the first part is the local scope. The local scope is the names inside a class or a function, and this will become relevant on the next slide, but the local scope of a class or function is always itself. So in the code that we just showed on the last slide, this part is the local scope. So the innermost function is the local scope. So that involves these 2 variables and everything in this function. Okay. And then the non-local scope is for midways between the local and global scope. And it's important for nested functions. That's why I just kind of gave a little intro to that. So here's a bigger portion of the code we just saw. And we can see that we have an outer function and an inner function. So the inner function, this is the local scope. And the outer function is the non-local scope for scope C. So if I have like an inner function, the non-local scope of that inner function will be the function that it's embedded in. So this big part right here is the non-local scope of the inner function. However, I also said that the local scope of a function will always be itself. So the local scope for outer, the local scope for outer is going to be this whole function, which is itself. All right, and then we have the global scope and the built-in scope. So now this is the whole block of code that I showed, and now we already know that this part has the local scope and the non-local scope. And let's go up here, we have scope A, which is the global scope, which is also sometimes called the module scope. And the global scope is outside of any functions or class definitions. So these variables, you know, they're not in a class and they're not in a method or anything like that. So they are part of the global scope. And then if we look down here, we have scope D, which is the built-in scope. And the built-in scope is kind of intuitive. It's just the stuff that's built into Python. So we don't define the method print anywhere in our code, but it's built into Python. So it's part of the built-in scope. All right, let's go. And then, yeah, here's just a nice little scopes graphic just to show exactly what we've been talking about. So the most specific scope is the local scope. And then outside of that is the non-local scope. And then the module scope or the global scope, same thing, is less specific than that. And then the built-in scope is kind of around all of that because it's just the stuff that's built into Python. So what does all of this stuff about scopes mean? We saw it a little bit, you know, we saw that the less specific can't access the more specific, and that's basically what scopes guarantee us. They guarantee us that more specific namespaces will never be altered by less specific namespaces. So if I have a function and I put variables into that function, nothing from outside that function is going to mess with them. And it also guarantees us that more specific namespaces will always have access to less specific namespaces. So what that means is within a function, I will still be able to access the global variables and stuff like that. All right, so at this point, ask any questions that you may have. I'd love to hear them. I'll just wait for like a minute or two while I get my life together. And yeah, so, oh yeah, okay. So now we're just gonna do like a quick demo of scopes again, just to reinforce it. So yeah, I'm gonna go to VS Code. Oh, was there a question? Sorry. Oh, yes, I also need to get my life together, all right. Okay, so I'm just gonna delete this. We already figured that stuff out. Okay, so this is going to be demo including non-local scope, because the one we did at the beginning was just like the global scope and then just one function. So let's do a little bit more. So this will be our global scope. And so that it's easy to read, I'm just going to call it global var, and let's make its message hello from global scope. Easy. Okay, and then I'm going to create a function called def regular func. Oops. Okay, and this will, and actually I'm just going to make the video. So I'm going to call this one non-local var. Spoiler, I'm going to be putting a nested function in. So we'll make that the message for the non-local variable, and then I will make def nested function. Oops, I keep doing that. Okay, and the message inside nested function will be local variable equals hello from local scope. Okay, and so now we can add this comment. This is going to be the non-local scope, and this is going to be local scope. Okay, now what? Let's try to access some of these variables. So within my nested function, let's print global variable let's print non-local variable, and let's print a local variable. Okay. And because I can't call nested function outside of here, let's just call it within regular functions. So we'll call nested function. Okay. And then outside of all that, we will call regular function. And that will give us all of the messages we need. So we have hello from global scope, we have hello from non-local scope, and we have hello from local scope. And that's because the nested function is, right now, it's our most specific scope, and so it's able to access all of the variables from all of the less specific scopes. However, if instead of calling this, I just tried to do print global variable, that would be fine because it's in the same scope. But if I tried to print non-local, see, it's like not doing the autocomplete thing, so that's a hint. But if I try to print non-local variable, it would not work because it's not defined, because it's in a scope that is less specific than the scope where non-local variable was defined. So that's just like another brief demonstration of scopes. And that's pretty much all we're going to do for scopes. All right, let me keep presenting. And yeah, again, if you have any questions, let me know. Okay, if not though, we will move on to classes. Oh yeah, oh, I forgot to press the arrow key, but what we just did is a quick live demonstration on how scopes work. Yeah. Okay, so what did we just do? We just did brief intro to scopes, and now we're going to be doing classes and everything under classes. Okay. So classes are really cool because they allow us to combine data and functionality. Oh, something in the chat. Ah, yes, poop. Classes allow us to create a new type of object, and instances of that object can be made. And if you don't know what instances are, that's fine. They're basically concrete occurrences of an object. So like you create like a version of that object. So like if I have animals, like an animal class, when I create an animal, that is an instance of that animal class. Okay, and then each class also has attributes attached to it. Now, let's just go over quickly what is an attribute, because I've definitely said that a couple times so far. So a class attribute is a feature or characteristic that belongs to the class. And it can be a variable, but it can also be a method. And basically what attributes do is they allow for an object to maintain and perform its functionality. So every attribute in a class has, something that it allows the class to do. For example, this dog, if our class is dog, we have a bunch of attributes here. So to maintain its state, some of its attributes could be like its name, its color, its breed, whether it's hungry or not. So those would be like variables. And then some of its other attributes can be methods. And so those could be like behavior. So I could have a method for barking, a method for fetching, or like a method for wagging tail, etc. I'm sure you get the deal. So that's what an attribute is. Now, another quick distinction that we have to make is instance variables versus class variables. And this is important because instance variables are data that is unique to each instance of a class, while class variables are common to all instances of the class. So for example, every car has 4 wheels, so that would work best as a class variable, whereas each car has a different name, so that would work better as an instance variable. Instance variables change depending on which instance of the class it is, whereas the class variables would be the same. So as you can see, both of these cars here have 4 wheels, so that would be a good class variable, except for this one's named Lightning McQueen, and this one's named the Mystery Machine, and so they have different names. So now let's get to how do we create a class? And basically, you do class and then the name of your class and then colon, and then you indent and you just do all of the statements of your class definition. So that could be declaring variables, declaring methods, any part of your class will go in the indentation. And when your class definition is entered, a class object is created and it's bounded to the class name given in the class definition header. So if I make my class name, then every time that I want to reference my class, I have to use the class name. All right. And then, so yeah, now we have our class object. What do we do with it? Oh, question possibly? Okay. So operations on class objects. Class objects support two kinds of operations, and these are, the first one is attribute references. The second one will be on the next slide. So attributes can be accessed with, class underscore object dot attribute name. So whatever I named it, and then dot, and then the name of the attribute. And attributes can also be assigned using equal signs. So I could say class underscore object dot attribute underscore name equals, and then whatever I want to set it equal to. So the second thing that we can do with class objects is instantiation. Sorry, it's a big word. And this is creating a new instance of the class. So we create it using function notation, which basically means the name of the instance equals, and then the name of the class and parentheses. And what this does is it creates an empty object, but that's not exactly what we want sometimes. So sometimes it will be good to create an empty object, but sometimes certain classes need to have certain things to instantialize them to have certain values. And the solution for that in something like C++ would be a constructor. And in Python, it's basically the exact same thing. So in Python, the constructor is called init. And let me just, sorry, it's a special function. And again, it's like the constructor in Python. It is the constructor in Python. And it's automatically invoked when a class is created. So it looks like this. We have def init, and then the parameter self, and then colon, and then whatever you're initializing and assigning attributes of your class, however many you need. Now, a question you may be having is, what is self? It's just this weird parameter that's there. Let's go over that quickly. So self is usually the first argument of a method, and it represents passing the instance object into the method. So it's like this in C++, but self also has to be passed in as a parameter. It's not just like automatically there. And just like this in C++, it allows us to access the attributes and methods of the class. So that's basically what self is. It allows us to do self.attribute and access whatever attributes are in the class. So the other thing is that back to, we don't want to create an empty object. We want to create an object and have it, already have certain values or stuff set in. So init can have arguments that were passed during instantiation. So that would look something like this. If I have an attribute and I want to instantize it to something, then I would pass argument 1 into init, and then in the init function, set self.attribute equal to whatever the argument is. And so how does init get this parameter? Basically, if I want to pass an argument into init, I would do it like this. So when I create the instance of the class, I would just do new instance equals class name, and then in the parentheses using the function notation, I would pass in argument 1. And you may be wondering, what about self? In the class declarations, we have to have self for the method declarations, like within the class, but when we're creating an instance of the object of the class, we don't have to have self in there. It will be there automatically as the first one. All right. Yeah. So what did we just do? We went over instantiation and the init function. So now we are doing now what, basically. So we have our object. Now what do we do? So basically, instance objects can only understand attribute references. And there's two types of attribute references, data attributes and methods. And don't worry, we'll be going over both of those things. So data attributes are instance variables, or in C++ terms, the data members of a class. And like normal variable creation in Python, they can spring into existence when first assigned to. So let's say I already have some attribute and it's already existed and stuff. I can access it with self.attribute equals. But if I want to create a new attribute, there's nothing special I have to do. I just also do self dot and then whatever the name is I want it to be and equals, and then I can assign it. So I don't have to go through any special creation process. So, and then the other, the other attribute type of attribute reference is methods, and methods are functions that belong to a class. So methods that belong to an instance of a class are called method objects, which means that we can also store them for later use. Which means that if I have, let's say I have a class called person, and that class has a method called greet, and I want to save that, I can do sup equal, or whatever name I want, equals person.greet, and then that means that I can save that method in sup and use it later. So we just went over like a bunch of stuff. I'm sure there may be some people that are confused. So if you have any questions, just type them in the chat and either I or a mentor will answer them. I'll just wait a second or two. And if not, then we will just move on. That's fine too. So now we're just going to do a quick demo, and this time I'm going to actually say what I'm going to do before I do it. We're going to do a very basic class demo, and then we're also going to do a demonstration of why you should be careful using mutable objects, which we went over in session 1 and 2, why we should be careful using them as class variables and not instance variables. And if that sounds like gibberish right now, don't worry, I will explain everything and it'll make sense in just a second. So that's what we're going to do right now. Okay, I'm going to close the terminal for now, and again, all of the code we're using is going to be on the GitHub link. So I'm going to delete this for now and start with a basic class example. What am I doing? Oh, I'm writing on the wrong document. Okay, so let's just call it class telescope. All right, and so I'm creating a class called telescope, and let's make one of its data attributes zoominess, how much it can zoom, and we'll make it 120. Now we're going to create the init function, and we're going to initialize the attribute of a class by passing arguments into, oh, I just realized I need to do full screen VS Code. My bad. Okay, so let's create init. And within init, we are going to have self, and let's say I want to have an argument called type. Okay, so then within init, I'm going to assign self.type set it equal to the argument that we're passing in, which is type. Okay. Now, what else should we add to our class? Let's say I want to be able to zoom in. So I'll create a function called zoom in, and of course we need self as the parameter. And all I'm going to do is self.zoominess and multiply it by 2. Okay, so that's our zoom in function. And then let's say I also want to zoom out. So we'll make a function called zoom out. And self is our parameter. And all we're going to do is literally the exact opposite, which is dividing by 2. Okay, so I have my telescope class. Let's let's mess with it a little bit. So I will create one telescope called Big Boy. Telescope, and I want my type to be big. So now when so I'm creating an instance of the class telescope called Big Boy, and I'm making its type, which is assigned in init, I'm going to make its type big, or the string big. Okay? And then let's say I also want to make a telescope called Small Boy, and its type will be small. Okie dokie. So now we're going to do some attribute references. All right. So let's Big Boy is really big and it can zoom in really far. So we'll do Big Boy dot zoom in. Okay. And Small Boy is not very zoomy, so we will do Small Boy dot zoom out. So even though they both have the same, they both are part of the same class, now their zoominess levels are different. Okay, so we can demonstrate that by just printing, and we'll print Big Boy dot type and Big Boy dot zoominess, and we'll print Small Boy dot type and Small Boy dot zoominess. Okay, so let's run this and see what happens. And so here we go. We get big, and then we get 120 times 2, which is 240. And then we get small and 60, because 120 divided by 2 is 60. So those are just some like really basic attribute references. Okay, so that is just like a basic class demonstration. And then the second thing I want to do, okay, someone said to increase the font size. I will do that right now. My bad. Is this better? Yes, no? I'll just wait for the chat to say.
It's good.
Good? Okay, cool. So, all right, font size increased. So, yeah, that's our basic class example. Now, let's go on and do the other thing that I wanted to do, which is a demonstration of why mutable class variables may not be a good thing. So let's create another class, or let me, why mutable class variables may be bad. Okay, so let's create another class, and instead of telescope, I'm going to create it to be called telescopes. Okay, and I'm going to create here a class variable that is mutable. Okay, so I'm going to create a list called telescope names, and I'm just going to initialize it right now to the empty list. We will come back to that. So now let's create my init function with self, and let's say I also want like a location. Okay, so then we do, whoops, forgot the colon, self.location equals location. So now my class has two attributes. It has the location, and then it has the list of telescope names. Okay, let's create a function for when we want to add a telescope name to our list of telescope names. So we'll call it add telescope name, and our parameters will be self, and we want the user to pass in a telescope name. Okay, and all we're going to do is self.telescope names to access our list of telescope names, and we'll append the telescope name that the user passes in. Sorry, lots of the word telescope. Yeah, so now our class is done for now. And let's start creating some instances of this class. So I'll create the first one to be called observatory1 equals an instantiation of telescopes, and we will pass in the location to be San Jose, which is definitely not where I live. And I will make the second observatory called observatory2, which is telescopes, and let's call it Los Angeles, which is definitely not where I eventually will live. Ah, and I spelled observatory wrong. Not that it matters because it's a variable name, but okay. Now, let's say that my San Jose observatory, I want to have one telescope name in its list. So I'm going to do observatory1 dot add telescope, and I want to add a pyroscope, and my spelling is really super good. So, okay, and observatory 2, I want to add another one. Let's call it, I don't know, a toy scope. Okay, so now, if everything works as we want it to, observatory 1's list of telescope names should have pyroscope, and observatory 2's list of telescopes should have toy scopes. So let's just verify that. We do observatory 1, or sorry, print observatory 1, and let's just print out the location and the telescope names. Nice spelling, on point. Okay, good. So we're printing out observatory 1 location and telescope names, and then we'll print out observatory 2 dot location and observatory 2 dot telescope names. Perfect. So this should print out San Jose, comma, pyroscope, and Los Angeles, comma, toyscope. Let's try it. And I'm just going to comment out the prints from our last demo. Okay, let's give this a shot. Oops. Add telescope name. Sorry. Okay. Okay, so this is not at all what we wanted. For some reason, Observatory 2's list of telescope names has pyroscope and toyscope, and Observatory 2's list of telescope names also has pyroscope and toyscope. So, like, what is going on with that? And basically, that goes back up to here, our big problem, which is that we have a mutable variable as a class variable, which means that every time I'm referencing it, which is I reference it here and here, I'm going to be modifying it. So even though here I did observatory1.add, I'm going to add it for observatory 2. And when I add it for observatory 2, I'm also going to be adding it for observatory 1. So how do we fix this? Basically, we take this and instead of making it a class variable, we make it an instance variable. Okay. So instead, I'm going to do self.telescope names equals empty list. So now I'm putting it in the init function and I'm making it an instance variable. That way, it won't be modified by for all of the classes every time I modify it for one class. So let's just make sure this works. And it does. It works beautifully. So now my San Jose observatory has just the pyroscope, and my Los Angeles observatory just has the toyscope. And so, yeah, in conclusion, I'll just put this as a comment. Don't use mutable objects as class variables. They will be modified by all instances of the class. And that's pretty much it. So let's just go back to the slideshow. And we are done. Or sorry, we didn't make a slide for a poll, but are we going to release the poll during the break?
No, I think that's separate. So we'll release the poll now and then break.
Okay. So psych, no break time. We will we'll do the poll first, and then after that we will do a break time. So yeah. Oh, and I will pause the controlling. I mean the. Okay, so for the first question, we just have a basic class, class student, and then an init function where smarts is the argument passed in, and self.smartness is initialized to smarts. Okay, and then we're going to create an instance of that class called anar, and the argument passed in for self.smartness is going to be over 9,000. So when we print anar.smartness, our output is going to be over 9,000. And so I think one person, it just selected it with a capital letter. That's fine. You got the right idea. That was a mean question. And yeah, apologies for any like indentation errors or something like that. Those are definitely possible. Yeah, Init might be, yeah, the way we sent the questions over, it ended up working strangely. Okay, so for the second one, oh yeah, I think that's, so the way this question was supposed to work is there was supposed to be a function A, and then function B was supposed to be a function nested in A, and then at the bottom of A we would call B. So if we tried to call B outside of all of that, it would not work. If we try to call B outside of A, we would get name error, name B is not defined, because we can't access B outside of A, because B is in A. So, but yeah, no harm for getting that one wrong, because the indentation ended up being kind of strange. All right, and then what is the most zoomed out Python scope? The most zoomed out Python scope, here, wait, we can actually, I can go back to the graphic if possible. Give me just a sec. I should have gone about this a better way, I'm sorry. Here, this is the one. So as we can see, the built-in scope is the most zoomed out scope for Python. All right. And then the constructor function for Python programs, yep, everyone got that. It's just init. And then here we have a class called CoolKid. And in CoolKid, the cool level of this class is initialized to the argument passed in. And then there's one other function in class CoolKid, which is take a nap, where their cool level is incremented by 2,000. So then we create 3 instances of this class. We create Alex, which has a cool level of 5,000, Jakob, which has a cool level of 4,000, and then Jakob's cat, which has a cool kid level of 4,100. And then we also have Jakob's cat dot take a nap. So Jakob's cat's cool level will be incremented by 2,000. So then the question is, which instance of the class has the highest cool level? And because Jakob's cat took a nap and incremented his score by 2,000, the answer will be Jakob's cat. So their cool level will be 4,100 plus 2,000, so 6,100. And that is the end. Okay. All right. So now I think I'm just going to go to the break slide, which is right here. So if we do a 10-minute break, we will come back at 7:03. Are you okay with that, Alex, or do you want us to come back at 7?
7:03 is fine.
7:03. Okay, cool. All right. And then, yeah, so, all right, yeah, come back at 7:03. And I will start this again.
Wait, would it actually be possible if I shared my screen first?
Sorry, Alex, do you mind saying that again? The music is like deafeningly loud.
Would it be possible if I shared my screen first?
Yeah.
Tense. Ooh. Okay, I'm gonna do that part again then. Okay, welcome to the second part of the workshop. In the second part, we're going to talk about mostly about inheritance, and then we're going to talk a little about the docstring, and then we're going to jump right into iterators and generators. So, inheritance. What is inheritance, right? So, if you've come from a CS31, CS32 background, you might have learned it. But for those who don't, inheritance allows us to define a class that inherits all the methods and properties from another class. Now, I realize that using the word inherits in the definition is a little bit cheating. But inherits really means that we're able to define a class that can share some of its methods and properties with other classes. And there's really two main bits of terminology that we should talk about, and that's the parent class as well as the child class, or the base class and derived class. So the parent class is the class being inherited from, and the child class is the class that inherits from another class, or rather it inherits from the parent class. So if we look at this little diagram here, you might think that, so here we have two classes. There's a bird class and a parrot class. Bird class is the base class or the parent class, and parrot is the child class or the derived class. And if you look at these little methods, this is not Python, unfortunately, but this is very similar. And if so, for example, every bird has a color. It can fly and it can tweet. But parrot is a bird, so it can also fly, tweet, and have a color. But parrots can also talk, and that's what we mean by inheriting methods and properties from other classes. And yeah, so we should go ahead and jump into an example. Can everyone see my code properly? Okay, so I'm going to start typing. So let's define a class. Okay, I'm going to define a class called person, and before we do that, let's talk a little bit about what we want to do. So I'm going to define a class called person, and every person should be able to introduce themselves. So they should have a name. And they should also be able to burp. Okay, because people should be able to burp. That's the thing. And so let's go ahead and define this. Okay, so this should be pretty old stuff by now. We have we should define an init function, pass in ourself, and I'm going to also pass in a first name and a last name argument to our person, because every person has a unique name. And we just want to print I am a person first, and then we're going to set our self first name attribute equals to the first name, and then self dot last name as the last. Okay. Now, so there's our name. Okay, we're done with the first part. Let's do the second part. Every person should be able to introduce themselves, so we can define a function called introduce. Takes in, remember, taking a self as a argument, and then we can just print, hi, my name is self.first name, self.last name. Okay, so we're done with this part. Now let's talk about burping. So everyone should be able to burp. This is pretty easy. You know, burping is pretty easy. So we should just simply just do just print burp. Okay, so that's our person class done. We define a person called X, and then we give it a name. So, and then we expect Jakob to be able to burp. Okay, and introduce himself. So if we run our code on this upper right button here, yes, correct. So I am a person because we call the constructor or the init function of person, and then we burped, and then Jakob introduced himself. Okay, right. Okay, so let's say now we want to define another class. Okay, let's define another, and we want to define a class called student. Well, a student is also a person. So we would also want students to be able to do the same things that a person can do. So students can introduce themselves. They should also be able to have first name and last name. And then they should also be able to burp. But then students should also, because they're students, they should need to be able to study. So this is what a generic student looks like. I'm sure all of you have done these things once in your lives. So let's go ahead and define a naive version of the student class. So from what we learned before, we can just do def init. This is pretty old news. And you know, if we didn't know anything, we would just want to okay, do the same thing as we did with person. So we would want to print, I am a student, and then print, and then self.first name equals first, and then self.last name equals last. And def introduce, I'm gonna do this real fast. I wish my typing speed was as fast as Nari's. You should see her typing speed. It's so fast. Okay, so first name, self.last name. And then def burp, passing in self, and then print. Okay. Now, so we're done. So with the person part of a student, right? Person can do these things. Students should also be able to do these things. But students also print studying. Okay, now this, and then if we, for example, if we define a new student, like, let's test that this works. Ooh, what just happened? Oops, okay. And, you know, if we run our function, invalid syntax, huh. Okay, let's try again. Okay. Aha, it's because I put def instead of class. I should be putting class to use the defining functions. Okay, so if we clear our terminal and then we print again, yeah. So we have our function works. Okay, I mean our class works. So we've defined an object of class student, but you know, this is not very efficient, okay? We're literally repeating the same code as we did here in person. And obviously we would want a student to automatically know that, okay, I'm also a person, so I can do the same things that a person can do. And how do we do this in Python? And we do this through inheritance. So we talked a little bit about why we want to do inheritance. Let's talk about how we can do this in Python. So I'm going to get rid of all of this, and all of this, sorry. And in Python, what we need to do is we just want to do, if you come from C++, you might expect that we just do something like this. We have a colon, and then we do public and person. No, in this case, so this is, Python doesn't do this. What you do in Python instead is in front of the class definition on the top line, you add parentheses as if you're defining a function, and then you add the name of the class that you're inheriting from the parent class. In this case, it's person as one of the arguments. And yeah, there we're done. We're done already. So here we have inherited from the person class. So now every student should be able to introduce themselves, burp. We also need to, in Python, it's good practice to call the init function of any parent classes that you're inheriting from inside of your own init function. And the way we do this is we have a person reference here, and so we can use it. So we can use person, all of person's methods and properties inside of our student class. And we simply just do this by using person.init. And we remember to pass it. We have to pass in ourself inside, and then first and then last. Okay, so now we should expect our student to be able to do all of the things that a person can do as well as study. So we can test this out. Okay, we can introduce, and we can also study. Okay, let's test it out. Run. Cool. So notice here that for 4 print statements, the first one comes from our init function here, and then we call the init function of person. So it goes all the way up here and then sees, okay, prints I am a person, and it does all of this stuff. And then we're done with the initialization or instantiation of our object. And then we introduced ourselves. Hi, my name is Alex Chow. And then we studied. Okay, cool. And this is how inheritance works in Python. And we can also do a little bit of extension. So let's say that our student, even though students can introduce themselves, they want to be able to introduce themselves uniquely from other normal people. Okay, because students are special, we're special, and we should not be introducing ourselves like the other common masses. Okay, so how do we do this? Okay, and so notice that here that when we call introduce, we already have an introduce in the form of person. How do we make our own unique introduce function as a student? And the answer is very simple. We just simply redefine it. So we just define another introduce function here. Here, if I can spell. Okay, and and we can just do our unique introduction. So we can do very similar things. We can do hi, my name is, and then self.first name, self.last name. Notice that we can still access self.first name and self.last name inside of student, even though we never actually defined self.first name, self.last name in our init function. It was all done up here, and so we can access it as if we had defined it ourselves. And, this obviously saves a lot of time and saves a lot of typing. So we did mention that we want to introduce ourselves uniquely, so let's add a bit of uniqueness to students. I am a nerd. Not me, but you guys, okay? So yeah, so this is how we introduce ourselves. And this is called overriding methods in Python. So it was as if that we had never we had never defined this in the first place. So now when we call introduce, let's test it again, and we run our function, we notice that yes, we did indeed call our unique function. And what Python does is that when we call introduce, it will first look inside of the student class, and it'll see if introduce is defined anywhere inside of student, okay? And if it is, then cool, we'll just call it and we're done, and we return, just as we did here. But if it isn't defined, so if we call burp, it will look inside of student. If it can't find burp, it will look inside all of students' parent classes. So it will go up to person and it will look for burp here. And if it finds it, cool, it will call it and return. But if it can't find it, if we just call y dot, then it can't find it anywhere in student, nor can it find it in person, so it will return an error. Okay, so this is overriding methods. And before we move on, notice here that here we have a print, hi, my name is, and then self.first name and self.last name, which is exactly the same as what we did here. And it's the entire introduce function. So as smart programmers, we can do a little better. So instead of rewriting out the first name, rewriting the entire line, we can do person.introduce, and then we call ourselves inside. So yeah, and yeah, remember to pass yourself object as the first argument of any method that you're calling from a parent class. Okay, so just to prove to you that this works, yeah, so it's the exact same thing. Hi, my name is Alex Jha, and I'm a nerd. So yeah. And if you come from a C++ background, you may be like, oh, hey, we don't need to do anything special to the introduce function in person's definition. So if you came from DS32, you may be familiar with something like, oh, do we need to do like a virtual keyword at the beginning to make sure that it can be overridden by a subclass? No, like Python does not have a virtual keyword, and if you're a C++ nerd, this basically means that all Python methods are effectively virtual. They have like, you can redefine any of a class's methods inside of a derived class. So student can override anything inside a person. Okay, now we're gonna talk a little bit about the super function. So, we've done a little bit of basic inheritance, and but notice here that we actually refer to person as we've referred to our parent class as person. So we had to actually do person.init and then pass in ourselves. Okay, but what if we have like multiple classes? We're inheriting from multiple classes. Okay, and what Python has is a function called super that is a function that references all the parent classes of a subclass. And then we use that super function inside of the subclass. And by using the super function, we don't have to use the name of the parent element. The derived class itself will automatically inherit the methods and properties from its parents. What this basically means is instead of doing person.init and passing in ourself, we just need to do super.init and then first and last. Okay, two things to note here. Notice that in super, we don't need to put self inside of inside as the first argument. And second thing to note that here is that super is the way you call super looks exactly the same as you would call if this was replaced with person. So you still use a dot operator, and we still do the init. And here we can do the exact same thing. Instead of doing person.introduce, we do super.introduce. And since we don't need to pass in ourselves, this is super simple, and it looks like this. Now we're done, okay? And just to check that this works, we're going to run our function once more and check that, and we'll see that it works. Okay, so why is super useful? Super is very useful in the case that we have a lot of complex inheritance going on, and a base class is inheriting from multiple classes. So for example, now I'm going to just type a lot of code, but so for example, we have an adult class that inherits from person as well, because adults are also people. And I'm just gonna go through a very quick class definition here. And then we're also going to use the super notation. So if we use the super notation, like so, and then we also have a UCLA students class. So that inherits from students and adult. I'm just going to check that this is spelled right. Student, yes, because UCLA students, we are adults, but we're also students, so we should inherit from both. And if we do ourselves and then first and last, UCLA students also have a UID, so let's add that here. And then print I am a UCLA student. And then super, we can call our super.init. First, last, and then self.uid equals UID. And then def study, we should also be able, actually we will do this now. Okay. And now if we defined a new variable called z, that's a new UCLA student. I should get rid of this s. New UCLA student, and its name was Einar, or his name was Einar. We could, let's just define it first, okay? And we could get rid of this. Run our code and see. Oh, we forgot our UID for Einar. Einar, what's your UID? This must be it. Okay, cool. So let's run our function. Let's run our code and see. I am a UCLA student. I'm a student, I'm an adult, and I'm a person. An adult, and I'm a person. Okay, cool. So it seems that our code works. And here we see a little bit about why super is useful. So instead of having to do, person.init and then adult.init, which it's just calling super saves us a lot of time, saves us a lot of work. And not just that, super is useful for another reason. And generally in Python, it is recommended to use the super function instead of directly using the parent class. Since the super function has well-defined behavior, even when there's really complex inheritance and going on. So if you're interested in learning more, you can read up about the super function and something called MRO, which stands for Method Resolution Order in Python. And those links are in the slides and README. Okay. And before any questions, first. Okay. Now, if you're new to inheritance, I want to talk a little bit about why do we use inheritance in classes and in objects? And turns out that inheritance is a very core part of the object-oriented languages. And not only does it save us a lot of time when writing code, but it also gives programmers a really solid foundation with which to work with. And it lets us create relations in our code. So we have two different relations. We have UCLA student, which is related to adult and student. And if you're just a programmer working in a really, really big company with lots of code, all you need to do is just look at the class definition of UCLA student, and you're instantly able to see what sort of relations that this class has with other classes, which is very, very useful. And it can help to structure very, very complex projects. Okay, now, if you come from C++, I'm moving on right now, by the way. So if you come from C++, you may be wondering, wait, private variables? So, you may be used to having to define some public methods and variables and some private variables. And it turns out that private variables, that cannot be accessed outside of an object does not exist in Python. So essentially, everything that we defined in our class student is accessible by anywhere if we have Y. So not anywhere, but if we can't have a notion of a variable that can only be accessed inside of these methods, inside of introduce, study, and init, for example. And that's just the way they design Python. There is, however, by convention, if you prefix an underscore to attribute names, this means that it is private. Okay, so what I mean by this is, for example, if we had a person and every person has DNA, so we underscore, this is the really simple example, so which is why I'm defining it outside here. And so if every person had a DNA and then secret DNA, and if we prefix this with an underscore, it still doesn't mean that nobody can access it. So if we did print x.dna, and then we can get rid of this, we should still see that we're still able to access a person's secret DNA. So in this case, it's Jakob's DNA. But in Python, all Python programmers will know, like, generally do not mess with a class's variable that has an underscore in front of it. So this is just by convention, and if you define it like this, people generally will not mess with it. Okay, this is just, yeah, it should be a feature, but it's not. It's just a convention. And if you want to, and there is also something in Python called like the double underscore, and that's called name mangling, which we won't get into right now. But it also has to do with like private variables and whatnot. Okay, so yeah, that's private information, but we can still access it. Okay, so we're done with inheritance. We're going to talk a little bit about other attributes that we can use, including the docstring. So we're going to talk about the docstring now. But before that, we're going to talk a little bit about classes in Python and special methods. So you may have noticed that every classes in Python, if there's a like an underscore in front of it, why is init has an underscore, init underscore. And in Python, this means that this function is special and it has a special purpose. And so, for example, init is the constructor of a class. And there are a lot of other special methods that we can define. One of these is the docstring. And the docstring is an attribute that is used for the documentation of a class. And it can be defined using the triple quote syntax here. So if we do, like, for example, I'm actually going to open the IDLE for this because it's simpler and easier to show. So if you define a class, just called yeet, and we should define an init. then print eat. And this is a valid class, and then we want to be able to use the doc string, right? And this is usually done at the front of a function. So if we do triple quotes, and in Python, doc strings is generally used for documentation purposes again, and inside classes, it is generally used as a good and brief description of a class. Now, a description of the class could be something like a class for Python to eat. Okay, and wait, oh. Yeah, so we finished our triple quote, oops. Syntax, and then we're done with our class definition. So now if we do something like x equals to a new yeet instance, we expect that it should print yeet because we have it in our constructor. But now we can also access, print x dot, we can access the doc string, okay? And here it sees that, oh, a class for Python is the yeet. Okay, if we print it out, we'll see that, okay, so it seems that doc string is basically just storing this string over here, and people can access it, and it's a good way, and it's a known way for people to use a doc string to get a brief and description of their class. So yeah, there's the doc string. It's useful, and yeah. Okay, so let's move on to iterators. But before that, we're gonna see if anyone has questions. Did go through a lot just now. Where's my chat? Oh well. Okay. So iterators. What are they? Okay. So you may have noticed from our session 2 or session 1 that we can iterate over any sequence using a for loop. By that I mean, we can define a list as 1, 2, 3, and then we can do for x in our list. We can print x. Okay, and this just prints 1, 2, 3. So we can just really simply do for x in lst. Okay, but what's really going on? Okay, here, and I never told you this before, and we never told you this before, but in Python, everything is an object, including a list. So a list, if we print list, we'll see that, wait. Okay, this won't work. Okay, that's okay. We can. I forgot how to do this, but but a list so this is an object of class list. Okay, and lists are objects, and the way Python iterates over these objects is through iterators. So every object in Python has these methods called __iter and __ next. And using these methods, Python is able to access is able to iterate over any object. So using these functions, Python is able to loop over the items in the object. So, let's see how this is done. Okay, and to prove to you that that a list is an object, we can go ahead and do x dot __ iter. Okay, let's see what this does. Oh wait, no, x is list. All right, I'm sorry. List dot __ iter. Yeah, so let's see what this gives us. Okay, so it gives us a list iterator object at some point in memory, and this is useless. So let's go ahead and store it in a variable. So let's do this, and now list it is an list iterator object. Now, how do we use this iterator object? We can do it.next. Okay, and it returns us the first item in the array. Okay, well, what if we do it.next again? oh, it gives us a second item in the array. Okay, so what if we do it.next again? Oh, it gives us the third item in the array. And what if we do it again? Because we've reached the end of the array. It throws us an error, and notice here that it gives us something called a stop iteration exception. Okay, so now we have a general idea of what iter and next does, right? It seems to us that iter returns an iterator object that we can use to iterate over. And then next enables us to manually iterate through all items of an iterator that was returned using our iter method. And when we reach the end and there's no data to be returned, it will raise a stop iteration. Okay. And together, the iter and the next syntax is called an iterator protocol. Okay. Now, before we move on, I just want to have a quick side note about the built-in next and iter functions. So next, so Python has two built-in functions called next and iter. They both take in objects, and what they do is they just basically call the next. The syntax is a little bit misleading, but I think this is wrong actually. Yeah. So I'm gonna fix this later, but you can think of this line, this first line, as being correct. Iter object is the same as calling object.iter, and this line is wrong because we have to replace this with an iter. So this line is wrong. So it should be it and then it. Yeah. So so now that we've I fixed this error, but we should go ahead and jump into an example and see what that is like. Okay, just to prove to you and to salvage myself from this mistake. Okay, so remember we have a list, okay, and we want to be able to do the exact same thing as we did just now. Let's just repeat the process, but instead of doing iter like so, we can do something called next list. And wait, no, sorry, iter list. Okay, and it seems to us that it calls the exact same thing. So if we do it, let's just do it2 again. Iter list. And then we have our iterator object, and it2 is a list iterator object. And if now we do next on it2, it gives us 1. And if we get next on it2 again, it gives us 2. And just to show that this is exactly the same thing, I can just interchange it with this, and it gives us 3. And if we do it again, it gives us a stop iteration. So this is basically just a cleaner, more fast, shorthand way of calling the .next and the .iter methods of an object. And everybody uses this in Python, so we're gonna start using this syntax from now on. Okay, so we've talked about how list has its own, next and iterator protocol, but how do we define our own, right? So, we're going to try and define our own iterator protocol, and I'm gonna jump into a new example, iterators.py. So we will start by defining a new class. Okay, so let's say that we want to define a class called number counter. Return us a counter that will count up by 1 to a certain I don't have, what was the command? Oh no. To a certain number. I forgot the shortcut for line wrapping, unfortunately. Yeah, so this is our number counter class. We just want it to return a counter that will allow us to count by 1 every time. So what does this class look like? So we have a class number counter. Then we should define an init function, just as all classes do. Number, and then self.max equals to num. Yeah, so right now this is our bare bones class. Now, how do we define our own iterator protocol? We should first start by defining an iter method. So we can just define a new function, and this function is a special method of that. It's called __ iter __. Okay, and this every function should take in a self as its argument, and then we want to do in our iter function, we want to initialize some things for the iteration to begin. So in our case, we want to do a count equals to 0 because we are, after all, a counter. And then we simply need to return something, because remember, when we called our iter function here, when we called list.iter, it returned us an list iterator object. What the heck is that? And when we define our own, we just need to return ourselves, because we ourselves is our own iterator. We are defining a class that will iterate over itself. Okay, and so all we need to do is return ourselves. Yeah. Okay. So this is the iterator function. Now, does anyone have any questions? Okay, cool. So notice that we haven't actually defined that our class currently doesn't work because we haven't defined a next function. So we should define a next function again with a special underscore to denote that it's special. And then what do we want our next function to do, right? First of all, we want our next function to manually count up by 1. So we should count equals to self count plus 1. And then we want to check if self.count is smaller or equal to self.max, then we will return self.count. Else, we should do something called raise stop iteration. I just did some things you may not understand, but remember that in our next function, when we iterated over our list, every time we called next, it returned us an item inside of the array or inside of the list. And it will always return, and every time we called it, it would return the very next one, almost as if it's remembering where we were at, even though it should have no idea of where we are currently at in the array. And this is done and this is all done in the next function. So here we are remembering what count we are on using the self.count variable. And every time we increment it by 1, we check if this count is less than or equal to our maximum. If it is, that means we're still counting up, so we simply return our current count, just as the array returned the item inside of the array. Else, it means that we've reached the maximum, so we should raise a stop iteration. Now, remember here that when we in our list, when we reach the end of our list, it also gave us something called a stop iteration. And stop iteration is just a special exception. Exception means in computer science, exception essentially means that the program is telling the computer to stop running, and there's something big that occurred, and we should return, basically. An error has occurred, essentially. And since this is an exception, in Python, instead of returning an exception, just as you would return something from a Python, you raise an exception, because exceptions are meant to be raised. And we do this using the raise keyword. So this is just something to keep in mind. You don't have to remember this, but this is how exceptions are raised in Python. And there are many different types of exceptions. Stop iteration is just one of them. Okay, so now we're done with our number counter class. So we can go ahead and copy and paste this into our shell. I actually want to start up a new one, so just because it's cleaner. Okay, so if we copy and paste this number counter, no error should occur. Cool. And if we did something, for example, like count 5, count 3 actually, and then we did number counter 3, notice that it's successful. And we have now done the exact same thing as the list. Okay, we can iterate over this count 3 as if it was a list. Not as if it was a list, but similar to how we did it with the list. So we can do iter, it equals to iter, count 3, no problem. And if we did next it, returns us 1, because we have counted up by 1 from 0. And then we do next it, we do 2, next it, we did 3, and then next it, we get another stop iteration, all right? And this is just to prove to you that this works. I'm going to go ahead and put this into a for loop. So I'm going to do a count 20 equals to number counter 20, and then we can do a for num in count 20. We can just print num, okay? And if we press enter, yes, it prints all 20 numbers, showing that we have correctly defined our function. So now you all should have a little bit more of an insight of what for in does under the hood, right? All it does is it does this thing, what we did up here. It calls the iterator, and it gets an iterator, and it just calls a next on it, and keeps doing that. But this is just a really shorthand way of doing it. And and this is true for all iterables, so all sequences. So if you did for letter in, for example, A, B, C, D, E, F, G, 1, 2, 3, 4, okay, and print letter, this is doing the exact same thing as just calling iter on this string, and then next it, next it, next it, all right? It's exact same thing. And yeah, so this is how Python does its for loops, and we can do we can make our own class and make our own iterator protocol so that we can do the same thing using our own we can do the same thing that we do as if it were a string in for loops. Okay, I talked a lot. Any questions? I see none, so cool. Let's move on. So what we did was kind of tedious, okay, just to implement some counting. So if you recall our number counter, we had to, just to implement some counting, really, we had to define a class, have an init function, and then we have to define an iterator protocol, like with using an iter, and then we have to return ourselves, and then create a next function, raise a stop iteration when we're done. Okay, that is kind of complicated, just to implement some counting. Can we do better, right? Is the question. And yes, we can. So we're gonna go over something called generators, which is a really simple method of defining our own iterator protocol. And so generators, not like these generators in Python are functions that returns us an iterator for us to use. And the difference is that instead of using return, we use the yield keyword instead. So that once a function contains a yield keyword, it automatically becomes a generator function. Okay, so now what I'm about to drop you is just a lot of knowledge, or not a lot of knowledge, but a lot of just facts that you just need to take in all at once. And you'll get a really clear picture of what generators are once we hop into an example. But for now, we need to just get through this and If you have any questions, please ask. Okay, so the difference between normal functions and generators, that is that, you know, even though functions and generators are actually defined the same way. So functions, let's just go over what a basic function is. So we only need return statements. So once we return from the function, we use the return keyword, and it can return anything we want. And once the function returns, the function terminates immediately. So you can recall that, you know, if we return from a function, it ends the function immediately, and everything inside the function, all local variables that we've declared, is discarded after the function terminates. This is not true for generators. So for generators, it contains yield statements, okay, instead of return statements. And when we first call the generator, it returns an iterator, but it doesn't start execution yet. This iterator, we can iterate through using the next function. And this next function will call the code inside of the function. And once the function yields, the function is paused and control is transferred to the caller. And local variables are remembered between successive next calls. Okay, what the heck was that? Let's see what this means. So, you know, notice that, you know, I did tell you just now actually that this was a lot of work for just a simple number counter. Let's see how we can do better, right? And we can do better using generators. So let's define a generator. And generators are defined almost exactly the same as functions. Do def, and then we can just call this count generator, so count gen. And it takes in an argument called a max. Okay, what does it do inside of this count gen? Well, it needs to count, and so we're going to do a for loop for I in range 1 to max plus 1, yield I. And we're done. We're actually just done with our generator. So we've reduced this amount of code into this 3 lines. And okay, I'm going to just run this in the IDLE first to prove to you that this actually works. And then we're going to go over what this function actually does. Okay, so we can just do for x in, oh, we also need to do, so we do count 5. Let's get to count 10 equals to count gen 10. And then just to prove to you that this works, we can just do next count 10, next count 10, and it works. And if we did, for example, count 9 equals to count gen 9, whoops, count gen 9, and then for x in count 9, print x, it prints us 1 to 9. So I've just demonstrated to you that this count gen thing is exactly the same as our number gen thing, our number counter thing that we defined up here. Now, but what does it do? So when we first called our countGen function, it returns to us a iterator object, all right? And once we defined our iterator object, we can iterate over it using the next function. And once we call the next function, it will run the code that's inside of our function. So what is our code doing? It creates a for loop, and for every number from the range of 1 to max plus 1, it will yield I. And what does yield do? Okay, so remember that yield, it's similar to return in that it returns us a value. So it returns us 1, and then it returns us 2. But what's different from yield to return is that yield actually pauses the function. So you can think and saves all of the local variables and the current state. So once, for example, if we're going through our first iteration where I is now 1, yield 1, so we will call yield 1, and what the function do is it's almost as if the function, this yield statement will freeze everything that's happening inside of this function, and it will exit the function, and then it will return us 1, okay? And then once we call next again, on this iterator, we will go back to our frozen code and it will unfreeze it. And different from normal functions is that our generator will save, it will remember all of the local variables and the current state of our function. And as it unfreezes, remember that I is still 1, and after we finish execution, I is now 2. And then we yield 2 again, and it freezes, and it pauses the function, and it exits the function, it returns 2, and it goes back once we call next again, and it unfreezes, I is now 3, okay? And so on and so forth until it reaches the end. And once it finishes the execution of this for loop, there is, and it exits, and we finish the execution of our function, it will automatically raise a stop iteration. So, just to prove to you that it does that, we can do count2 equals to count gen2, and then next count2, next count2, and next count2. And yeah, so it raises a stop iteration, just as it should. So, so what we did right now is we redefined this much code, and we rewrote it into 3 lines of code. And that is the beauty of generators. Any questions? Yeah, thank you, Python developers. Okay, if we have no questions, then we've actually reached the end of the workshop. I have something more to cover. They're called generator expressions that are very similar. It's very similar to list comprehension, but for generators. And instead of using the square brackets, we use parentheses instead. There's more about this on the README, so I'm gonna leave it for that today. This is just a little bit of syntactic sugar. It's not necessary. Just like how this comprehension is not necessary in terms of functionality, it just shortens the code. Generator expressions just shorten the code, and it may make it more complicated in certain situations. But if you want to learn more about this, go to the README. There's a tiny section about it. It takes like 5 minutes to read, but it's a cool little intro to generator expressions. But apart from that, we don't have any more time. It is 8. So thanks for coming. Next session, we will be covering automation and file I/O. And please remember to fill out our feedback form, please, please. Did you know that, like, I don't know, like people not realize that you can win money from this? There's, in terms of participants, I don't see many participants. So if you fill out the feedback form, there's a really high chance that you'll actually win some money, which, it's free. It's just Amazon gift cards. It's money. So please fill out the feedback form. We really look at the feedback, and we really take our feedback into account. So thank you. And that is it from us. Thanks for coming. And yeah, I'll put on the lo-fi again. Woo. And if Jakob would end the recording, that would be nice.